16th January 2026. It is a crash course, crash class of IGCSE physics. And right now we are starting general properties of waves. And let's start with some basic definitions. The first definition you should know what is a vibratory motion. Consider this is a metal bob, and this metal bob is suspended with an inextensible string, and now it is suspended vertically. Right now, the sphere is in equilibrium. So this position we can say equilibrium position, or we can say midpoint, or we can say mean position, etc. Acha, if I displace this sphere from its equilibrium position to the right extreme, and this position is called extreme position. And if I release now, then you will observe the sphere begins to and fro move, to and fro motion about mean position. And when any object moves to and fro about its mean position, then such a motion is called vibratory motion. When an object moves to and fro, when an object moves to and fro about its mean position, then it is called vibratory motion. And when this bob completes one cycle means this is right extreme, and when you release this object from this right extreme, then obviously the bob moves towards the mean position, then it will move towards left extreme, and then it will return back to the mean position. And in this way, now it has completed its one cycle. And when it has completed one cycle, when it has completed one trip, then this is called one vibration. So one complete trip or one complete cycle is called a vibration. Acha, if you have a stopwatch and you are measuring the time of one vibration, if you are measuring the time of one oscillation, then when you switch on a stopwatch as you release the bob, and when the bob completes one oscillation, then the time to make one oscillation, the time to make one vibration, it is called time period, and it is always denoted by capital T. Capital T is the time period notation, and it shows the time to complete one oscillation. But sometimes an object vibrate very fast. Consider we have a rubber band or a string which is stretched between two supports. Consider these are two supports, and between these two supports, this rubber band is stretched. And when I plugged from the center of the rubber band and then release, then this rubber band also performing vibratory motion. But this vibratory motion is so fast, it is making too many number of oscillation. It is making too many number of vibrations in 1 second. And the number of oscillation, number of vibration in per unit time, number of vibration, number of oscillation in 1 second. It is called frequency. So frequency is number of vibration in per unit time, number of vibration per unit time. And now the last basic definition. Now the last basic definition. Acha beta, do not write during my class, because when I will complete my class, I will share you the PDF in which I am writing, as well as I will share you my class recording so you can revise through this recording as well. So focus on understanding and do not copy. And if there is a mathematical work, then I think mathematical work should be noted. Otherwise, you should not write the definitions because I will share you this PDF just after my class. So the next heading is amplitude. Sir, what is amplitude? Amplitude means this is mean position, this is extreme position. And the separation between mean position to extreme position, this is called amplitude. Mean position to extreme position, mid position to extreme position, it is called amplitude. So the distance between mean position to its extreme position during a vibratory motion, it is called amplitude. So before starting the topic wave, you should know these basic definitions, and I think you have understood all these concepts. Vibratory motion, when an object moves to and fro about its mean position. One complete trip is called one vibration, and the time to make one vibration, this time is called time period. Sometime object vibrate very fast. So if you count number of vibration in 1 second, then this is called frequency. What is amplitude? Sir, amplitude is the distance between mean position to the extreme position. It is called amplitude. So these are basic definitions which we have discussed. And now I am starting the main topic. The main topic of the today's class is, sir, what is wave? So let's start. What is the meaning of wave? Consider, consider this is a string. This is a rope, and this string is connected with a vertical support, and its free end, consider it is in my hand. And when I vibrate up and down my hand, I am moving my hand up and down. Then the kinetic energy of my hand enters into the string. When I move my hand up and down, then the kinetic energy of my hand enters into this string. And then you will observe the string starts motion like this. And when string moving like this, then actually the particles of string, this is one particle, this is the other particle. I am showing few particles. I cannot show all the particles. Consider this particle is moving up, and later on it will move down. In the same way, this particle is moving down, and later it will move up. And you can see, sir, this particle is vibrating. When my hand moving up and down, then kinetic energy of my hand enters into the string, and now the particles of a string, particle of medium, starts vibration. Particle of a string starts vibration. So I can say when energy of my hand enters into a string, and a string is a medium. When energy enters into a medium, then particles of medium start vibration. And by this vibration, energy moving, traveling through medium, energy moving, traveling through this medium. And this mechanism is called wave. So we can say the transfer of energy mechanism, the mechanism of transfer of energy, the mechanism of transfer of energy, all kind of energies are transferred by wave motion. And what is wave? So I'm repeating, sir, when any kind of energy enters into a medium, then medium starts vibration. Particles of medium start vibration. And by their vibration, this particle is vibrating, this particle is vibrating, this particle is vibrating, particles are vibrating. And by their vibration, now energy traveling through the medium. So waves are used to transfer energy. The mechanism of transfer of energy is wave. And when energy enters into a medium, then particles of medium start vibration, and by this mechanism, energy is transferred from one point to the other. Energy is transferred from one point to the other. So this mechanism is called wave motion. This mechanism is called wave motion. And you know, there are different types of waves. And mainly there are two types of waves. Number one, transverse wave. Number two, longitudinal wave. Usually we study longitudinal wave in the chapter of sound, but right now I am giving you just definition. What is transverse wave? Sir, in the above example, you can see, sir, in this string, actually energy is traveling from left to right. Energy is traveling from left to right. From my hand is moving up and down, and the energy is traveling from my hand to the wall. So this is the direction of wave. This is the direction of energy. And now you can see the particle of medium are vibrating perpendicular on the wave. Particles of medium vibrating perpendicular on the wave. Sir, wave traveling horizontally. Right now, wave traveling horizontally and particles vibrating vertically. And when particles vibrating vertically, it means particles vibrating, particles vibrating perpendicular on the wave motion. So whenever particles are vibrating perpendicular on the wave motion, then this kind of wave is called transverse wave. And conversely, if particles vibrating parallel, if particles vibrate parallel, then it is called longitudinal wave. But right now, I am not interested to explain longitudinal wave. When we will study sound, then I will explain you. I will show you some animation as well because longitudinal wave is very difficult to express by static picture. So right now we are confined only within transverse wave. So in transverse wave, you can see the particles are vibrating perpendicular. Particles are vibrating perpendicular on the wave motion, as well as in this transverse wave, you should know this portion which is above the mean position. This portion which is above the mean position, this is called crest of the wave. And the portion of the wave which is below the mean position. The portion of the wave which is below the mean position, it is called trough. It is called trough. अय हाय अयान भाई, आपने क्लास का सारा मोमेंटम तोड़ दिया आपके लेट आने से। अयान क्यों इतना लेट आ रहे हो यार? अयान, आवाज आ रही है आपको? अरे यार, आप हमेशा लेट आते हो और आधा आधा घंटा लेट आते हो। अच्छा जी, नाउ वी वर स्टडीइंग अबाउट ट्रांसवर्स वेव. इन ट्रांसवर्स वेव I was teaching, so the region above the mean position, it is called crest. The region below the mean position, it is called trough. So we can say a transverse wave composed of crest and trough. A transverse wave composed of crest and trough. And if you measure the distance from crest to crest, then this is called wavelength. If you measure the distance from trough to trough, this is called one wavelength. But this is a very simple definition. But in exam, usually they do not ask like this. You should know one more definition about wavelength, which I am going to explain. The length of one cycle, the length of one complete cycle, it is called one wavelength. What is the mean? Sir, this cycle is starting from this point, and at this point, you can see, sir, one cycle is completed. One cycle is completed, moving up, moving down. So in this way, one cycle is completed, and the length of one complete cycle, it is called one wavelength. So you should know three definitions for the wavelength. Number one, crest to crest, it is one wavelength. Trough to trough, it is one wavelength. And the length of one cycle, the length of one cycle, it is called one wavelength. So in this way, we have completed the definition of wavelength. And one more concept, then I'm shifting into the past paper sheet. The last concept is, sir, consider this is a crest, and in this crest, the maximum height of the particle, the maximum height of the particle, this is called amplitude. Amplitude is the maximum height of any particle. It is called amplitude. And I think if we study from past paper sheet, then I think it will explain in more detail these concepts. So let's start from the past paper sheet. All these concepts which I have explained right now, these are in this sheet, which I will share you just after my class. And right now I am solving question number one. And this question number one from May, June 2017, paper 42, question number six. And the paper code of this class is 0625. And there are two students in this class for Ammar and Arisha is 5054. But the main theory is same, okay? But right now we are dealing this question that is from 0625 paper codes. Question number one from May, June 2017. You are given a wave graph, okay? And in this wave graph, the question number one is, what is the amplitude of the wave? Arisha beta, can you read what is the amplitude of the wave in this question, Arisha? You are saying is it 6.8? Okay, but give me the answer ना. I'm asking you a question. अंदाजा थोड़ी चलेंगे बेटा. You should give me the perfect answer. अच्छा बेटा Faria, can you read what is the amplitude of the wave, Faria? 4. अच्छा जी, you are wrong ना बेटा. अच्छा Manur, can you read what is the amplitude of the wave? Manur, what is the amplitude of the wave? Can you read? 4. Okay, it means the students are not able to read amplitude. Actually, this line is the mean position. 3.4, let me check. Let me check. ठीक है ना? Let me check. You said 3.4. I think Navia saying 3.4. Okay. Actually, this the horizontal line is the mean position, and this is the extreme position. And you should read what is this number. You know this is 6. This is 7. This is 7. Okay, this is 7 between 6 and 8. It is 7. This is 7.2, and this is 7.4. The extreme point on the graph paper, it is 7.4, and the starting point is at 4. At 4, it is not at 0. So extreme point is at 7.4, the midpoint at 4.0. So Navi answer is right. That is 3.4, and the unit is in centimeter. The unit is in centimeter. But Manur, the horizontal line is the mean position, and this horizontal line is at 4 centimeter mark. Okay, beta. And the extreme position, extreme point is at 7.4, and the separation between 7.4 and 4.0, it is 3.4. And the unit is given in centimeters, so it is 3.4 centimeter. And Mahanur, I am asking you one more question, which I have taught you right now. Mahanur, beta, what is the wavelength? Can you read what is the wavelength, Mahanur? Beta, can you read what is the wavelength? This is the starting point. This is the length of one cycle. Then can you read what is the wavelength? 7.4. Okay. Acha beta Faria, can you read what is wavelength? Faria. Arisha beta, can you read what is one wavelength? Arisha? Yes, you are right. No, 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 no. It is not three. Three कहाँ से इसमें नजर आ रहा है बेटा आपको? The starting point is 4, not 4. Actually, it is along x-axis because wavelength is along horizontal axis. Amplitude is along along vertical axis. Amplitude along vertical axis, okay, and wavelength is along horizontal axis. So along horizontal axis, the starting point is 0, and the final point, this is at 30 centimeter. It is 30 centimeters. So the starting point is at 0, and the final point is at 30. So the length of one cycle is 30 centimeter. So the 30 centimeter is the wavelength. 30 centimeter is the wavelength. So very simple concepts, but my students could not grasp it. I am repeating. Okay, consider this is transverse wave. Yes, this is transverse wave. In this transverse wave, this is the amplitude. Yes. This is amplitude. Yes. This is amplitude. And what is one wavelength? Sir, one wavelength is either length of one cycle. This is the length of one cycle. Horizontally, wavelength, vertically, amplitude. Okay, or it may be the distance from crest to crest. It is one wavelength. The distance from trough to trough. It is one wavelength. Or the length of one cycle. The length of one cycle. It is called one wavelength. Okay, so you are not able to read that question, but I am asking. I think I should ask you questions. But Arisha, can you define what is the amplitude? कैन यू डिफाइन व्हाट इज एम्पलीट्यूड? एम्पलीट्यूड की डेफिनेशन आती होगी तो बेटा रीड करना भी आ जाएगा आपको. अरीशा, व्हाट इज एम्पलीट्यूड ऑफ द वेव? मीन पोजीशन टू द एक्सट्रीम पोजीशन, क्योंकि वो ट्रक में भी हो सकता है ना बेटा. फ्रॉम मीन टू एक्सट्रीम. ओके, यू आर राइट. बेटा मानूर, कैन यू डिफाइन व्हाट इज वन वेवलेंथ? महानूर, कैन यू डिफाइन व्हाट इज वन वेवलेंथ? Wavelength, length of the wave or length of one cycle. Length of one cycle, okay, or crest to crest or trough to trough, all these concepts are wavelength, okay. And now Manur, I am asking you a question, one more question from the past paper sheet. The question which I am asking Manur, this question is here, Manur, I am giving you some option. This option is A, This option is B, this option is C, this option is D. You are given four options. Okay. And now my question, Mahanur, I am asking you, Mahanur, what is the amplitude? Is it A, B, C, D? What is the amplitude? Mahanur, what is the amplitude? And as well as I should add this option as well. A, B, C, D, E. What is amplitude? Manur, you are saying B? हाँ बेटा Manur, is it B? Okay. अच्छा बेटा Amina, can you answer me? Okay, 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 beta Manur, I have noted your answer. Amina, beta, can you answer me? What is amplitude in this in these A, B, C, D, E option? Amina, हाँ बेटा? Yes, you are right. Mahanur and Amina both are right. Sir, option A is amplitude. You are right, beta. Okay, this is amplitude. Acha, beta, Amina, I am asking you, what is one wavelength in this option? What is one wavelength in this option? Which option is the one wavelength? हाँ बेटा हाँ हाँ बोले no 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 one wavelength हाँ yes no not a C not a C neither C nor E हाँ बेटा Faria can you answer Faria Faria what is one wavelength Arisha what is one wavelength yes you are right the length of one cycle the cycle is starting from this point ending at this point so this option D is one wavelength the cycle starts from this point. The wave is moving down, then wave moving up, then moving down, and at this point, one cycle completes. And one cycle completes, so this length is called one wavelength. This cycle is called one wavelength. ठीक है अच्छा बेटा मानूर इज स्टूडेंट ऑफ ग्रेड 9 तो उनसे तो मैं एक्सपेक्ट कर सकता हूँ कि वो आंसर करने में प्रॉब्लम करें लेकिन ऑल अदर स्टूडेंट्स महानूर एंड अयान they are a student of grade 9 they are not going to appear in exam but all other students are going to appear in exam after 3 or 4 months but you are all students are lagging it is a very simple concept the distance from mean to extreme it is amplitude and the length of one cycle is one wavelength. Okay, so this question is completed. In this question only, we have to mark what is wavelength and what is amplitude. And now I am starting one more concept in this sheet. And the next part, we have a one formula in this chapter. We have one formula in this chapter, and the formula is the speed of the wave. The one formula in this chapter is the speed of the wave. Okay, and speed of the wave. Note down this formula, beta, please, because this is a mathematical part. You should all student note down this formula. Speed of wave denoted by V, and it is the product of frequency and wavelength. The product of frequency and wavelength. The product of frequency and wavelength. It is called speed of the wave, and it is the only formula in the wave chapter. Okay, so now we are solving question number 18. Sorry, question number 14. The question is calculate frequency of a wave, and you are given speed as well as wavelength. So if I put speed 0.15, note down this calculation. Speed is 0.15. Frequency, sir, we have to calculate. Wavelength 0.030. And if you are calculating frequency, then beta Navia, can you answer me? If you divide 0.15 by 0.030, then what is frequency, Navia? 5 and all the numbers are given in at least two significant figure so we should write 5.0 5.0 and the unit of frequency is hertz the unit of frequency is hertz. The unit of frequency is hertz. So this is the only formula in this chapter. Speed of wave is the product of frequency and wavelength. In this question, we are given speed as well as we are given wavelength. We are calculating frequency and the frequency is 5, but I am writing 5.0. Why? Because all the given numbers are in at least two significant figure or at most two significant figure. So I am writing final answer in 2SF. So this question is also completed, and now I am moving forward. The next question is explain what is meant by transverse wave motion. Transverse wave motion. So you should answer, sir, when particles of medium, do not copy, I will share you PDF. When particles of medium vibrate perpendicularly to the wave motion, to the wave propagation, then this is called transverse wave, and it is composed of composed of crests and trough. So this is the proper definition of transverse, and in the next part they are asking draw a diagram of transverse wave, which I am not drawing because in the next question I have copy pasted another transverse wave. This is transverse wave. This is question as well as this is answer. And in this drawing, you have to label what is one wavelength and what is the amplitude. So to draw amplitude, I am drawing a vertical blue double-headed arrow, and I am writing this is amplitude of the wave as well as the length of one cycle. The length of one cycle. This is called one wavelength. Length of one cycle, it is called one wavelength, denoted by this symbol. It is read as lambda, and the vertical distance is amplitude, and the horizontal length is one wavelength. So this question is also completed, and now question number 19 we have already done, but one part remaining, the last part. In this question, again, they are asking calculate frequency of the wave, and you know the speed of the wave is the product of frequency and wavelength. So speed is given 8 centimeter per second. Frequency is given, sorry, wavelength is given 2.5, and you are calculating frequency. Navia beta, can you answer 8 divided by 2.5? 3.2 hertz. So this is mathematical calculation. I think you should note it. Speed is the frequency, the product of frequency and wavelength. Speed is the product of frequency and wavelength. And now the B part of the question. The B part of the question, it is a very difficult question in which I am giving you a new concept. And the new concept is when we solve question number 19, then you can see along x-axis, along horizontal axis, you are given distance of the wave. Remember, if along x-axis, if it is a distance, then this length, the horizontal distance, is called one wavelength. Then the horizontal distance is called one wavelength. If distance along x-axis, if distance along x-axis, then the length of one cycle is one wavelength. Trough to trough, one wavelength. Crest to crest, one wavelength. But if Along x-axis, you are given time. If along x-axis, if it is a time, then the length of one cycle is called time period. So whenever you study a graph of wave, then you should check it first. What is along x-axis? What is along horizontal axis? If the distance is along horizontal axis, then the horizontal distance is called one wavelength. But look at this question. In this question along x-axis, no distance. This is time. And if this is the time, then the length of one cycle from this to this is the length of one cycle. It is not one wavelength. It is called time period. It is called time period. Okay. It is called time period. If distance along x-axis, then length of one cycle is wavelength. If time is along x-axis, then the length of one cycle is called time period. Okay, this is a new concept. And now I'm solving a question. The question is you are given a transverse wave and you have to draw another wave. You have to draw another wave which has half amplitude. Half amplitude. This is the original amplitude. This is you are given original amplitude. And now I am going to draw another wave with half amplitude. This is approximate half amplitude. Okay, so I will draw another wave with half amplitude as well as, sir, greater frequency. Greater frequency. Sir, what is the meaning of frequency? Sir, frequency means number of cycle, number of oscillation per unit time. If there is greater frequency, if there is greater frequency, then there will be greater number of cycle within the same time period. Consider this is 0 second, consider this is 10 second. Consider this is 0, this is 10. Okay. The given initial wave time period was 10 second. 10 second. And now I am going to draw greater frequency wave. So greater frequency wave will take less time. Sir, why? Because frequency is number of oscillation divided by time. If frequency is greater, then time will be shorter. Time will be shorter. Greater frequency means shorter time period. And if shorter time period, so I can say I am going to draw another wave which will complete its one cycle within 5 seconds. So I am drawing. I am drawing. Look at this drawing. This wave. Look at this wave. The amplitude of the wave is half. The amplitude of the wave is half, and greater frequency means less time. And you can see this wave is completing just 5 seconds to complete one cycle. And now I am drawing another cycle. Again, it is completing within 5 milliseconds or 5 seconds. I am drawing one more. I am drawing one more. I am drawing one more. Okay. And all these waves which I have drawn, I'm converting their color with green. And all these waves having half amplitude, having half amplitude and greater frequency. And I think you should draw this diagram. Otherwise, you can't understand what I am saying. You should draw this diagram. You should draw this diagram in your notebook. You should draw. Sir, we are given a black wave. The amplitude of the black wave was larger. and this wave having half amplitude. So I have reduced the amplitude and I should erase the blue lines as well. I should erase the blue lines as well because the blue lines are boundary. It is an imaginary line. It is an imaginary line. It is an imaginary line. I think you have drawn. Do not draw here. It is just a rough diagram. The next C part we cannot solve because it is about sound. The C part is about sound, which we cannot solve right now. But the next part is again very simple. Sir, you are given wavelength. Sorry, you are given frequency. You are given speed, and they are asking to calculate wavelength. They are asking to calculate one wavelength. So again, sir, V equal to F lambda. V is the speed, and speed is 5800. Speed is 5800. Frequency is 1100, and you can calculate wavelength. So wavelength is equal to 5800 divided by 1100. Then, beta Nevia, what is the answer? Beta Nevia, what is the answer? 5.27 or 5.3 meters. Okay, okay. So we have a very simple formula. V is equal to F lambda. Drawing is completed. This question is already done. And tomorrow we will start a new concept of wavefront. Tomorrow we will start a new concept that is called wavefront. So right now